Hello and welcome to Techcyte's latest webinar, episode 12. We will start momentarily. A large group just joined, so we will get started. Hello and welcome today to Techcyte's webinar, episode 12, Mastering Whole Slide Imaging, Lessons Learned from 11 Years of Scanning Sparse, Liquid, and Smearable Samples. We are excited to share a bit about that journey. I am delighted today to welcome Dr. Amy Wood, who is our scanner's product owner. I'll introduce Amy in full here in a few minutes. I want to give a bit of an introduction about what we'll cover today and about Techcyte, and then we'll turn the time to Amy, who will enlighten us on this journey over the last decade plus, what we've learned around scanning tough to scan sample types and how that can help you in your lab as you consider automating and digitizing traditional microscopy. I'll share a bit about Techcyte, then we'll let Amy articulate the scanning challenges and solutions that we've discovered, how new development happens around image acquisition and AI and workflow software development, making sure those developments are actually applicable in clinical settings. There are challenges around real world applications that she'll articulate. Where are we headed? The future with scanning tough to scan samples. And as always, we'll have time for Q&A. I do want to be clear, put your questions into the chat anytime throughout the session. We will try to address your questions at the end, and any that we don't get to, Techcyte will follow up and answer your question in a personalized way. So first, a bit about Techcyte. Some of you are new watching and hearing about us today. Techcyte is an AI and workflow software company. We were originally a technology transfer out of the University of Utah and ARUP Laboratories. That was that 11 years ago milestone. We have built a platform that helps laboratories across the environmental, veterinary, and the human market, which is what we're focused on with you today, to help them automate and digitize microscopy. We all are facing in the laboratory space the industry-wide shortage of skilled microscopists, staff who are capable of identifying objects of interest and making clinical decisions. Techcyte's platform helps with that by helping laboratories go digital and then be more efficient and more accurate in calling out those pathogens and other objects of interest that clinicians have been identifying for centuries to help improve patient, animal, and environmental health. We do have dual headquarters in Europe and the United States, and we have been growing rapidly for many years. It's really fun to talk to you today, though, about the journey during that decade. Our mission in building this platform is to positively impact the health of those humans, animals, and the environment through the use of AI. We plan and are doing that by becoming the preferred digital pathology and diagnostics platform across each of these markets: human, veterinary, and environmental. A bit about this human side of our platform. On the left-hand side, you can see the various medical discipline areas in which Techcyte offers solutions. We have a histology suite, parasitology suite, bacteriology, all of these different areas where we have solutions within each of those suites to help those departments, those laboratories, to go digital and to use AI to augment their skilled technologists, their skilled pathologists' work to help them make decisions faster. On the right-hand side, you can see a variety of the features or critical components of our AI and workflow software platform. First and foremost, of course, we are an image management system, a viewer and storage capabilities, but much more beyond that. We have really focused for the last decade on building a platform that is driven by the laboratory's workflow. We have watched, observed, and sat by you experts to make sure our platform actually fits in with your existing workflow and helps you glean the benefits, the efficiencies, the accuracy gains of moving to a digital workflow. It also includes homebrew and third-party AI, all in a compliant SOC 2 environment, recognizing the importance of scalability and security. We also enable reporting out through the LIS, through our open API, connectivity to the EHR and LIS as well. And in our image acquisition front, which is what we'll focus on today, we've really tried to nail how do you get a clinically viable image digitally from a glass slide that is either easy to scan, which Amy will paint the picture on the front end, and then really we'll focus on the tougher to scan sample types. So with that background about Techcyte's platform, I want to introduce Dr. Amy Wood, Techcyte's scanners product owner. Amy has a undergraduate degree, a bachelor's degree in chemical engineering, and then she earned a PhD, a doctorate in mechanical engineering. Amy is a chief Scrum product owner, and she leads our laboratory's research around good image acquisition. Pre-Techcyte, she worked at a university for several years teaching product development and design processes. She's been with us about 2 years, and so far, she's already built 13 scan profiles for new products for Techcyte, with many more coming in the pipeline. Amy, I'm delighted to welcome you today. Thank you for stepping away from the lab and all this R&D you're doing to talk to our prospective customers about this unique challenge.
Thank you. I'm so excited to be here and kind of share the work that we're doing. First, I want to talk about our lab spaces. As Jacob said, we have 2 locations. I work in the Utah office, and we also have an office in Luxembourg where we have, between these 2 places, we have over 25 scanners on site. This represents over $1.5 million in hardware investment. And I think this is really important because for us to really understand the scanners and the different strengths of each and how we can implement these in a clinical setting, we have to be able to interact with them and have time with them, and we've invested to be able to do that. The original scanners, I guess the very first one came out in 1994. It was created by James Backus, and it was, the first of its kind, which was very exciting. It cost about $300,000 to install and took over 24 hours to scan a single slide. So obviously we've come a very long way since then, but most scanners have continued to focus on tissue sample types. That's the image we can see here. So these ones are they were a good first step, right? They're a bit easier to focus on because they are sort of this monolayer. There's a consistent thickness across the sample. It's very easy to tell where the sample is versus where it isn't in the stop image here. And in the bottom image, you can see that we're focusing on really large objects, the whole cell. And so it's easier for the scanners to find focus on these types of samples. When we get into these liquid, sparse, and smearable sample types, which is what Techcyte's been focusing on, none of those things are true. The thickness can vary drastically with smeared samples. We can see this image on the left here is a respiratory sample that was quite thick. And then on the right side here, we have the CSF sample that was cytospun, but it looks like there's almost nothing there. But there is sample here that we hope to detect on the scanner. And so being able to accommodate those different thicknesses is really a challenge for us. Also with the CSF in general, there's a lot of sample types like this that are so sparse, it's hard to find where the sample is so that we can focus on it. Then when we get into wet mounts, we see that there's sort of this band of liquid, and some objects will float up to the top of that liquid, and other objects will settle down to the bottom. And so that also makes it hard for us to choose the right Z layer that has the objects we're interested in. Yeah, and it's hard to focus, in the part that matters for diagnosis. So now I'd like to talk about a few of the challenges and sort of solutions that we've come up with at Techcyte to overcome these challenges in the earlier days. So before my time at Techcyte, our first opportunity was to work on veterinary O&P. There were definitely some challenges here. One is that the mounting media is sort of this sticky, sugary substance. And so just being able to find a scanner manufacturer who was willing to let us test these inside their very expensive equipment was a challenge. And then here you can see on the top we have, oh, sorry, as I was saying, some kind of flowed up and some flowed down. And so that makes it hard to find the right layer. And then as you can see on the top here, we have some really small images or small objects that we're looking for. These can be from 5 to 14 microns. But in the same sample, we also have these really large organisms we're looking for, these eggs that are, between 50 and 100 microns. And so developing a process for scanning that can handle both of these extremes has really been a challenge for us. One way that we've dealt with that is by working with scanner manufacturers to build an API that would allow us to use what we call fiducials. So this black circle in the center shows kind of what that design looks like. We take that in sort of the millimeter size range and put it onto our glass with ink. And so these are printed onto the slide. And we can use that to help kind of guide the scanner to focus in the right area. So in this top corner here, you can see the blue at the bottom is the glass of the slide. And then this yellow in between is our wet mount sample. And inside of that, you can see these little dots. These are the eggs that we're looking for. And then at the top, we have glass again for the cover slip. So basically our idea was to take this cover slip and print right on the bottom of it. You can see those black dashed lines, there's 3 there. If we print right on the bottom of it and then put that directly onto the sample, then we have this opportunity to take this macro image, find where the fiducials are, and then sort of guide the scanner to focus at that Z layer, because that Z layer is where our eggs that we're interested in are. And so this is something that we used first for vet fecal samples. Then we also started using that with vet urine. But here we have the opposite sample. This is a sediment, so everything sinks to the bottom that we care to scan and have in focus. And so we use the same principle, but instead of the ink under the cover slip, we have the ink right on top of the slide. And there again, we can sort of guide the scanner to that area, to that Z level, and scan there so that we can have really clear focus on the objects that we care about. We also implemented this with our air quality samples to detect mold. So again, we use fiducials printed onto the cover slip to find where that mold is, because it's directly under the cover slip. And we've also been using this more recently in human for gram-stained bacteria. So these are the 2 kind of slides at the bottom there on the right. We have one with a circle and one with a square. We use these outer shapes from the macro image to help the scanner determine which scan profile we're going to use. We'll talk more about what that means in a minute. But each different preparation, so a smear would go on this square one, and that would be something that's typically thicker. And then the cytospine samples would go on the circle one, and then we would, because it's thinner, we would focus a bit lower in the Z level to find the bacteria that we're looking for. So originally we started with vet samples. We collaborated with Zoetis, and that collaboration has resulted in millions of AI-based diagnoses for vet clinics around the US and all over the world. This helps us to get really beautiful looking scans that can be used to quickly diagnose the things that our model includes. And now, as I said, we sort of transitioned the same learning into the human space. Sort of the next exciting thing that we're working on now is smart volumetric scanning. Recently, scanners have started to introduce external robotics. So you can see in this image here, the gray and blue in the middle is a robotic arm from Universal Robotics. This allows the robotic arm to gather samples that are on the table on the left side here and then put them into the scanner to be scanned. The scanners here in this image are the boxes kind of on top of each other there. There's 2. And so this is sort of a new idea, taking the robotics out of the system so that we can have it be a little more adaptable. I also want to talk about volumetric scanning. So on some of our scanners, like for tissue, typically we would just take one Z layer, and that would give us enough information that we could make our diagnosis. For some of these more complicated samples that we're working with, one layer isn't enough. And so we need to have a couple of different layers. And with some of our scanners, we can actually take multiple layers and sort of combine them or fuse them into one single image that gives us sort of a 3D look through the thickness of the sample. So this is really exciting because it allows us to see details that we weren't able to see with just a single layer. The smart scanning piece is that we can, so as the image is being acquired, we sort of take one area, and then as the scanner moves to take an image in the next area, we can take that first area and run our classifier on the scanner as the scan is happening. So while the slide is still loaded there, we can start the classification process and start to find where those objects of interest are. And because we're doing that while the slide is still loaded, that gives us a lot of options for making decisions based on the information that we're getting from the classifier. So one of those things we can do is to set a count limit for blood, for example. When we find 100 cells, we can stop the scan, because after that, we don't need any more area. We have enough to make our diagnosis. That can really help us decrease the scan time, which can help us to improve the throughput in the lab. Another exciting option here is being able to save all of those different Z layers, but only around the objects of interest. If we have a really sparse sample, we don't care about having every layer of that blank space in between. We only care about having it over the objects we are interested in that will help us with our diagnosis. And so because we have this feedback happening inside the scanner, we can save just those areas, and that helps us to reduce the scan time, to reduce the file size, and also reduce the upload time so that it can get to pathologists and the lab techs more quickly. All of these kind of together allow us to have some really key breakthroughs, which are enumerated here. The first is lower cost per scan. This is always important for labs to make sure that it's financially viable, and so these are great benefits for that. The second is automated QC. If we can get some feedback while the slide is still in the scanner, then we can do quality control there and correct any issues before the slide is removed from the scanner. Another is this volumetric scanning that I was talking about. It really opens up a lot of different sample types for us, because sometimes one layer just isn't quite enough for the samples that we're working with. Fourth, we can add some redundancy here. So as you can see, there's two different scanner heads and one arm loading both of them. So if one scanner is undergoing some maintenance or it's down for some reason, the lab can continue to move forward with the other scanner and not have to kind of pause all work. And then the fifth is that scanners are matching the volume requirements we're getting from labs in terms of physical space that they take up. Here, because we have sort of these tables and they're stacked on each other, we're able to put everything in a smaller footprint, and that makes it a lot more accessible for labs who are always struggling to find space that they need. Okay, so next I'd like to talk through some of the new sort of processes that we're using to develop these solutions. The first thing I want to talk about is image acquisition. Obviously, the AI is a really exciting part, and that definitely improves efficiency, can improve accuracy, but we have to be confident that we have a model that's well trained. And so if we can have great images going into the model, then the model can perform really well. So getting those great images to start with is really a challenge. The different sample prep and staining methods are critical to finding a way to scan consistently. And once they're deployed in the clinic, the scanner has to really fit into the workflow and be able to reliably produce these really great images that were used to train the model. So we have to kind of keep up that level as we go into production, and having a daily QC check is a really critical step there. Now I want to talk a bit about what we mean by scan profiles. So the scan profile defines the settings that are used to optimize the scanning process for each particular sample type. We have to create a new scan profile for each different sample type, but also for each different scanner that we work with. Each of the scanners have different features and different sort of benefits to them, and so we have to adapt those. Even for the same sample type, we have to adapt that for each of our scanners. The things that we look for are the number of layers that we're scanning, if one will be enough or if we need more, the scan area that we want to look at. We prefer to have more area so we can really feel comfortable that we have everything we need to make a good diagnosis. But the larger area we scan, the longer the scans take, and that affects our throughput. So trying to balance that. Next is the focus methods, whether it's the sparse sample that we're using fiducials for, or whether it's a thicker sample that we can just focus directly onto the sample. Also, different color adjustments. Each scanner has different settings that we can use to adjust the color. And we really work hard to to adjust the color settings so that the final image looks how techs are used to having it look. We really want to minimize barriers from moving from manual to digital, and having it look familiar is a really important step there. And then also we look at basically choosing the correct set of settings or profile based on the barcode. Often the barcode for the sample will have information about what sample type it is. And so if we can use that in the scanner to automatically select the right group of settings, then that's just one less thing we have to rely on the user for, and so that makes it a little more robust and lowers the risk.
Amy, if I could jump in here.
Yes.
These scan profiles are one example of, for more than a decade, Techcyte's R&D groups, right? We spent millions of dollars in engineering resources to figure out custom scan profiles, custom settings to get good clinically viable images of these tougher to scan sample types. This is where, as Techcyte's team meets with laboratories, we talk about what are you looking to digitize? Let's talk about the samples that are of greatest interest to you today based on your staffing challenges, your turnaround time requirements, things like that. And then we say, based on your needs, this scanner with this type of scan profile to digitize that. Those are the conversations that are happening. Our team is having every day on virtual calls, in lab visits, and at the booth. So I love the work you and the team are doing in the lab and have done for many, many years. And it's really fun. It seems like every month there's another scan profile released for a different sample type. But these are the kinds of things where when we understand a lab's needs, we start to articulate to them, you probably need this scanner with this scan profile installed by Techcyte. So that's the consultation that we seem to go through a lot. I just wanted to point out that the scan profile is a critical piece of that.
Yeah, thank you for that. So as we're optimizing our scan profile, we have a process that we follow for each of our different scanners, sort of based on the years of learning, like Jacob was saying. At first, we're just kind of trying to see what would work, but now that we've had those years of experience, we have a more formal process for developing these profiles that allows us to do it in a more systematic way and more quickly and efficiently. So typically what we do is scan the same slide with multiple different settings so we can see which setting looks the best. So here you can see we're looking at a very similar sample, maybe kind of small for you, but let me highlight some differences here. These two images were created using different settings on our scanner. So look at this first one. At the top there on that cell, you can see we have a pretty clean, crisp edge around the top, but in the bottom one, that edge got a little bit blurred. And so what's happening here is basically the focus on the second one shifted more towards just above or just below that cell. And so it's a little bit out of focus. Likely it was shifted by this big dark group beside it, which we'll talk about in a minute. But we kind of do these different tests and look for these subtle differences so that we can find the very best settings. I'll show one more example here. On this one, you can see in the top, we have inside the nucleus, we're seeing this great detail. We see this kind of structure in the middle there on the bottom one. And then at the top, we can start to see some of those structures as well. On this bottom example, on that bottom nucleus, there's still something there. We can tell it's a nucleus, but we don't have quite the same detail. And those details are what the lab techs and the pathologists are looking for to make a confident diagnosis. And so those details are really important to us. So we do a lot of sort of side-by-side testing until we can iterate through and get to the group of settings that works the best.
And Amy, I just wanted to mention that Techcyte has many in-house laboratory professionals who now are with Techcyte full-time, but we also, a huge shout out to our wonderful partners, collaborators, ARUP Laboratories for our parasitology solutions, getting their feedback over the years on the clinical viability of a scanned image, and Mayo Clinic for all of our other indications, as we've collaborated with both of these institutions to get their feedback from their experts, making sure that that image is good enough to make a call. Really appreciate their collaboration. They with our lab and Amy's team, that's a pretty powerful team.
Yeah, it's really fun to sort of be on the more technical side, the engineering side, and understand how the scanner works. And then to be able to collaborate with these people who understand the lab so well, who understand the sample type so well. Yeah, it's a great pairing for sure. So some other things to consider as you're kind of thinking about how digital cytology could fit into the lab. There's a few things. One is obviously getting a good image so we can have a strong model. But there's a lot of other things related to the workflow that are important here. So one that we want to point out is whether a certain scanner is sold or supported in your geography. If it's, sort of in your region, then it's a lot easier to manage shipping, maintenance, calibration, any requirement for an on-site visit. Those things are much easier if it's supported in your area. Another thing to look at is FDA or CE-IVDR clearances. This is really important for a lot of our indications, and so making sure that we have a scanner that's kind of moving towards that is really important. Another is DICOM support. DICOM is a file type that is the industry standard in radiology and is quickly becoming the industry standard for these sample types as well. And so, if that's something that's of interest to the lab, it's important to choose a scanner that supports that file type. Some other things are different focusing techniques, whether we're using this extended depth of field fusion, where we take multiple layers and kind of combine them, or if one Z layer will be sufficient, then we can do that. Or using the scanning API, where we have the fiducials and we're kind of guiding the scanner to focus in a certain area. All those things we can consider, and different scanners have different abilities in each of those areas. Another thing is that we need easy to use and reliable trays for holding the slides. These are, hardware that's going to be loaded with slides and unloaded hundreds of times. So we need to make sure that that's going to work for the lab and that they're going to be robust enough to last over time. If we're doing wet mounts, typically we like to keep them flat so that we don't disrupt the sample. If they do get turned, it's not like they spill out, right? There's enough surface tension there that it holds on, but we'd like to minimize disruption to the sample. Another is error notifications. Being able for the scanner to be able to know that something's wrong before, a scan happens and before it gets sent to pathologists is really important for us. And so we've worked with different scanner manufacturers to create these different notifications so that we can understand how well the scanner is functioning. Another is web versus premise-based software. So some of the UIs for the scanners are web-based and others are on a computer that's attached to the scanner in the lab. And so understanding which one will work best for your lab is important there. Another is PHI reduction. We want to be very careful with all patient information, and the different scanners have varying degrees of the ability to protect that information. Another that I mentioned is barcode-based scanning profiles. So being able to read in the barcode that's already being used in the lab to indicate the sample type and confirm that we're using the appropriate settings for that sample type. Just a few more here. One is integrating with other automated systems. So if you have, an automatic smearing machine or stainers or cover slippers, making sure that the prep method the lab wants to use is compatible with the type of scanner that we want to use to digitize. Another is being able to support multiple objectives. As you can see in this image here, we have some scanners that have multiple objectives in a turret, like we were used to seeing on a microscope. Others don't have that feature, and so making sure that we can match needs there is important. Some of our scanners only offer 4DX scanning, but some offer both 4D and ADX. So depending on the sample type you're interested in, we may have to have the 4DX, and that sort of is a smaller group of scanners where that's available. There's also options for oil and water immersion, which can be useful for certain sample types. Some of the scanners offer streaming uploads, so they'll take one portion of the image and start uploading it as it's acquiring the next portion of the image. And this is really important for tests that require a fast turnaround time, like frozen section. So that can be a key deciding factor there. Another is the operating system that's attached to the scanner computer, making sure that that will integrate well with the IT of the lab, and also making sure that we have the security requirements that the lab's interested in. Okay, so now I want to talk through some of the challenge that we've seen specifically for human samples in clinical settings. And first I want to talk about fecal trichromes. Here we have a smeared sample. They're generally not too sparse, so they're maybe relatively easier to focus on. When we first started here, we were told that we needed to scan the entire sample area. And being able to do that at ADX takes a very, very long time. so long that it wasn't totally feasible for the lab financially. And so we were very careful to work with our data partners and sort of slowly decrease the area until we could find the area that was sort of the least amount possible so we can keep the scans moving, but enough that we can get the sensitivity we need. And finding that balance is something that we handle very carefully because we want to make sure that we're having great patient outcomes. So being able to sort of minimize that to maximize our throughput was important. Also for fecal trichromes, 90+% of these are going to be negative. And so the AI is really great at searching through those and being able to screen out the negatives. But if we have one that we think is potentially positive, we have to go back and confirm on the glass manually the diagnosis. And so for this example, we need to be able to load the slide into the scanner, complete the scan, but then put the slide back into a place where a person can come and quickly grab the few that they need to be able to manually review. So tracking the physical location of the slide is really important for this workflow. That's quite different than the fecal wet mount samples, where because this is a wet mount and it's kind of drying over time, as soon as we scan it, these are going to be discarded. And if we need another look, we have to prepare another sample. So being able to accommodate that difference in workflow was, a challenge that we had to work through. These slides must be loaded flat. As I said, we'd like to disrupt the sample as little as possible. So keeping them relatively flat as they're being loaded and unloaded is really important. And then with these wet mount samples, because they're liquid, even when the slide's sitting still, there's still some movement happening inside the fluid. But then when you add to that the scanner kind of moving it along so it can scan across the sample, that also causes the objects to move a little bit, and that can cause the blurriness that we, of course, don't want to see because we need to be able to diagnose. And so figuring out a way to accommodate that was really a challenge that we've overcome in the last year or so. Another wet mount that we work with is urinalysis. Here we have samples that are only stable for a few hours. In this top left corner here, we have a cast. These break up really quickly, and so it's not possible for a lab collecting these samples to send them to us and have us do our testing here. We constantly need fresh samples, and that testing has to happen in their lab so that we can ensure that we can, find enough of these objects to train our model. So that was a challenge here. As you can see, also there's no stain, and so a lot of these objects are really pale, and we're not able to use color to kind of differentiate them in the way that we do with other slides or other sample types. These samples can be very sparse as well, so that has a lot of challenges for us, and sometimes fiducials are required for scanners to be able to focus because they're so sparse. Another one I want to talk about is bacteriology. Some of these samples are really thick, like we showed, but some are really sparse, like this one. And so being able to locate the sample and focus on the Techcyte instead of on some dust that's on top is really important for these sample types. Some of these objects are only a micron across. That really is pushing the limits of what we can do with an ADX scan. And so, being able to accommodate that was something that we really had to work through. And again, sometimes fiducials are needed for these really sparse sample types to be able to find focus in the right Z level. Last thing I want to talk about cervical cytology. This is one that we've been working on for many years. The challenge here is that we have to be able to scan every cell that's on the slide. That's required for us. Also, we need to scan single cells like we see at the top and bottom here. But we also need to be able to scan these big clusters, this dark group that we see in the center. Being able to have a scanner that can adjust to, that kind of single layer down on the glass up to this large group of cells is really difficult. Also, with this sample type, techs and pathologists prefer to see Z-stacks, especially for these large clusters, this dark piece in the middle. On a microscope, you can kind of move up and down and see what's happening in the center of this cluster. And so being able to sort of replicate that in a digital way has been a really important feature that we're working on. With this one in particular, our AI model supports multiple different scanners. So each one has a little bit different color or like focusing method that kind of makes the look a little bit different. Sometimes we use water immersion, and sometimes we have slightly different magnifications. And so here with our model, to be able to be trained on this wide variety of variation in how the images look really makes our model quite robust to any potential changes that might happen in the future. Now, if the stain is a little bit off for a couple of days, we can, the model can still handle that because it's used to seeing this variation in color, for example. And so being able to have multiple scanners in one model really makes it a robust, high-performing model. So looking ahead a little bit about what's next, these are things that we're excited to be working with our scanner vendors on. And yeah, a couple sort of highlights that we wanted to share is that we're working towards scanning fluorescent sample types. You can see heme fish here in the center. This is a very different sample type with very different challenges. And so being able to work with our manufacturing partners to be able to accommodate these samples has been a fun challenge that we're working through. Also being able to do rapid turnaround applications like frozen section. Here we need to be able to scan and have results within a couple of minutes so the operation can proceed. And so having that really tight turnaround is unique to the sample type, and we're working through that now. Being able to use multiple objectives to optimize the scan area and the resulting image is another thing that we're excited about. Being able to sort of mix and match within the same slide so that we can optimize that scan time is really important for us. And then being able to run AI on the scanner's computer so that we can make decisions as we're scanning to, save certain areas or things like this to optimize our scan time, but also our file size is a really exciting thing that we're working through now. So generally, when it comes to choosing a scanner, the AI piece is really exciting. It can help improve the efficiency and the accuracy, but it's only viable if, first of all, we have a good model that we can consistently get those images, but also if it fits the cost and the footprint and the workflow of the lab. Being able to, have the users who are interacting with it not be constantly frustrated by, something about the scanning process is really important for us. And so we've done a lot of work to sort of streamline that and make that as user-friendly as possible. At Techcyte, we have a lot of experience scanning a variety of samples across multiple industries and across multiple scanners. And because of that, we've seen all the challenges that can come up in the lab, people preparing on the back of a slide or things like this, right, that we have seen so that we can build those things into our system to make sure that either they don't happen or we can detect them when they do. So yeah, we'd like you to consider Techcyte as a scanning advisor because we have sort of this behind the scenes look at all the scanners. We can really work with you and help you choose the right scanner, the right scan profile, all the things that you'll need to implement this in your lab. Thank you.
Amy, thank you. I'd add to that last comment, the Techcyte is also a reseller of many of these scanners in various geographies. And so being able to get the combined system, the Techcyte AI and workflow software, plus the right scanner for your purpose, all from Techcyte, simplified one package combined system is handy too for the customers. Boy, I learned a lot. It was fun to see those real world examples of this journey the Techcyte research and development team has gone through. Really appreciate it. We did have a few good questions come through, Amy, and we'll try to get to those here quickly. Andy asked, how do you manage that 100-cell cutoff for blood cells? I know this is a specific example you gave, but do you help each lab that wants to scan meet their own requirements, or do you have a general workflow that users are expected to adjust to on their own to meet their validation requirements? I'll let you take a crack, and I might add something.
Okay, perfect. Yeah, I think generally there are some things that, for it to work as a system as a whole, the lab does need to make some adjustments. So sometimes that looks like, adjusting barcodes or how we label or things like this. But generally, we try to be really flexible and work with the labs on their specific situation. With blood in particular, if 100 is not the right number for you, for your lab, then we can definitely make adjustments there and make sure that it works for each individual site.
Agreed. Audrey asked, what image file formats can you work with? Can you work with different vendor scanners? So I'll let you speak to image file format. I know you spoke to DICOM a little bit, but why don't you elaborate on DICOM and other file formats we're compatible with, please?
Yeah, so DICOM is sort of the one we prefer. We see that as becoming the industry standard here, and so we want to sort of be at the forefront of that. There's a lot of benefits to DICOM in terms of bringing in metadata so we can, have not only the barcode, but other information about how the scan was created. That is really useful for troubleshooting. So that's one benefit there. Also, DICOM's a bit more stable for long-term storage. And so that's why I think a lot of labs are moving towards that. But DICOM's sort of new for us, for this industry. So we definitely support other sample types as well. Typically, this looks like SVS files or TIFF files. We can support JPEG files. So yeah, we have a variety that we can support.
NDPI, yeah, several.
Yes.
MRXS. Yep. And then, yeah, we do work, Audrey asked, do we work with different vendor scanners? Absolutely. So we really appreciate our scanner partners. It's been a wonderful journey with them. You saw different images of a few in today's presentation. We have learned a lot with them, and we've pushed the limits with many of them, and really appreciate their innovation with us as we have really become the world's leader at scanning sparse, liquid, smearable sample types. You saw a lot of that color today. So Techcyte does resell many of them, or we can consult on many of them too that we might not resell, but can introduce you to the scanner manufacturer based on the application you're looking to digitize. Amy Martin asked, in traditional parasitology, we use the peaks and valleys method for smear prep. Have the systems been assessed for this style of preparation?
Yeah, this was a big project for us. So when we first started getting samples in, they were the traditional peaks and valleys. And because of the difference in thickness, right, you kind of move the slide up and down as you're smearing. So you have these really thick spots and then these really thin spots. And this was a bit before my time, but I heard lots of stories about doing a lot of testing in these different sort of sections of the slide. And they found that the thinner areas were a lot more clear and were more what the techs were used to seeing. And so, yeah, we experimented back and forth with the lab on the prep quite a bit, and eventually settled on more of like a monolayer smear that's a more consistent thickness. And we found that was a bit of a change for them, but allowed us to get these really beautiful images that were able to improve their workflow. And so for the labs that we've worked with so far, it was worth it for them to adjust their prep so that they could use our system.
And sensitivity actually improved, and there are peer-reviewed publications out there in the Journal of Clinical Microbiology, several publications at ASM Microbe, and some of our other webinar content from laboratory professionals. So great question.
Mm-hmm.
Steve asked, are you working on being able to analyze microplastics in air, water, or blood?
Yeah, so a lot of the projects that we've worked on so far are sort of labs coming to us saying, hey, can we work on this? And then, if they're able to provide samples, and we can do that testing because we have the scanners in our lab. So microplastics is something that we haven't worked on yet, but if we had the right partner, we would love to work on that.
Great. There are several more. Techcyte will follow up with each of these questions and get you an answer. We will wrap the webinar portion itself now. As you have any follow-up questions, please don't hesitate to reach out to us. This webinar will also be available on our website and on YouTube. Again, Dr. Amy Wood, thank you for your time and expertise today. It's exciting to see the advances over the last decade, and Techcyte looks forward to talking to all of you about what your digitization needs are. Again, thanks for tuning in into today's episode, and thank you again, Amy.
Thanks so much.